Eliminations usually is a favorite among most students. What it involves is making your variable cancel. So the way that we do that is you have to make one of your variables be the opposite sign but the same terms, and then when you add them together they cancel. Elimination, the easiest way to do it is to just go ahead and show you the example. Now, a thing that you need to keep in mind about elimination is with elimination you cannot use fractions. You have to use whole numbers. The second thing that you need to keep in mind about elimination is you always want to try and make sure you are starting from standard form in some way. Okay, so the definitions of standard form again are that you cannot have fractions and you cannot have decimals. They have to be whole numbers. Okay. Now, when you're working with them, you can get some fairly interesting results, and some of them can be some pretty big fractions. So let's just kind of work through this and see what happens. So I want to use the elimination method, which means I have to make these two equations where one of the variables is going to cancel out. So the first thing that I would notice is that I have a 5x and a 3x. I have a 6y and a 2y. So looking at these, they are not the same and they are not opposite. So I'm going to have to multiply one or both of my equations by another value in order to force them to be the same. Well, the easiest thing to do is to keep the top one alone but multiply the bottom. So we're going to multiply this bottom equation here by 3. And the reason we're going to do that is because when I multiply this 2y, I'm going to get a negative 6, so when I add them together they cancel. So let's go ahead and look at that. My top equation stays the same, so 5x plus 6y plus 8 equals 0. And then my bottom equation I multiply by 3. So 3 times 3 is going to give you a 9x. 3 and negative 2 is a minus 6y. 3 and 18 is going to give you plus 54 equals 0. Now, here is the beauty of elimination method. Elimination method says we are going to go old school and we are going to add our equations together using the idea of vertical math. Pretty sweet. So what that means is we are simply going to do just that. 5 plus 9 is going to give you 14x. 6 plus negative 6 is 0. 8 plus 54 gives you a positive 62. 0 plus 0 is 0. So if you look, I've gotten rid of one of my variables, which means I now have an equation I can solve. So here I'm going to solve this for x, so I get that 14x is equal to negative 62. So x is equal to negative 62 over 14. Remember, you always want to simplify, so x is equal to negative 31 over 7. And here is my first solution. Now once you find one solution, you take that solution and you simply substitute it back. So I would go back to the original system and I would choose one of the equations that you want to use and you're going to substitute in for x. So let's use the bottom equation just for grins. So we're going to use 3x minus 2y plus 18 equals 0. Substituting for x, we get 3 times negative 31 over 7 minus a 2y plus 18 equals 0. We are going to distribute through. We get negative 93 over 7 minus 2y plus my 18 equals 0. I want to get rid of this fraction just so I can make life a little bit easier on myself. To do that, I have to multiply this entire equation by that 7. So we're going to multiply each term by that 7, and so this becomes negative 93. We're going to have minus 14y. We are going to have plus 126 equals 0. we're going to combine our terms. So we're going to have 126 minus 93 is going to give us 33 minus 14y equals my 0. So negative 14y equals negative 33. So y is going to be 33 over 14. And so here would be my other solution. Now, you always want to get in the habit of checking your work. And checking your work says plug your solutions back in and make sure they satisfy your equation. So once you do that, you have to classify. This was a one solution system with solution results of negative 31 over 7 and 33 over 14. Okay, so there you have it, elimination. Alright, let's go ahead and do one more example. So here again we're going to use elimination, and we've got our two equations here that we're going to use. And so just like before, the first thing that I would do is I would combine my like terms. So I'm going to look at my top equation here. I have x plus y equals 3x minus 1. I'm going to go ahead and move my x over. So I have 1 minus 3 gives me a negative 2x plus y equals negative 1. Now, a lot of students always ask me, well, why didn't I move the x the other way? The reason for that is because elimination must use standard form. And as a reminder, that means ax plus by equals c. So your x and y terms have to be on one side, which means when you are combining your terms here, instead of like normal where we may solve for y right away, we have to move the x to the other side so we resemble standard form. Now I need to also do that to the bottom. So here I have x minus y is equal to 1 minus x. So I'm going to take this x and move it. So x plus x is going to give me 2x minus y equals 1. And so here I'm going to go ahead and set up my new system. So this is my new equations, these two here. So let's set up that system. We are going to have negative 2x plus y equals negative 1. And we have 2x minus y equals 1. So here's my system. If you look at these two here, you could clearly see that when I go ahead and use my elimination method, which says to add, I have negative 2x plus 2x gives you 0. I have y plus negative y gives you 0. And then I have negative 1 plus 1 gives you 0. Again, just like with substitution, don't panic. This right here, again, is called a true statement. It means it doesn't matter what x and y are, you will always get an answer. Therefore, this means that we have infinitely many solutions. Alright, so there you have it. Two fairly straightforward examples showing the elimination method. So if you have any questions on that method, please let me know. If you have any examples that you wish that I would work out for you and walk you step by step, I'd be happy to do that. Just send those to me or reply to them in the comments. Other than that, I hope you had as much fun as I did. It was a blast, and I look forward to seeing you next time.